Okay, so today we're going to be exploring question 9 of the Module 5 Lesson 2 textbook assignment. And question 9 here is we have a point on an industrial flywheel and it experiences a motion described by this function, and h is the height in meters and t is the time in minutes. So we have to find the maximum height and how many minutes is the maximum height reached, the minimum height and how many minutes the minimum height is reached, for how long within one cycle is the point less than 6 meters above the ground, and determine the height of the point if the wheel is allowed to turn for 72 minutes. So let's get started here. Here is our function, and we can find that our amplitude is 13, our midline is 15, and our period is 2 pi over b, so 2 pi divided by 2 pi over 0.7. So we're going to get the 2 pi's are going to cancel out. So our period is 0.7. So let's get started on with A, the maximum height of the point. So the maximum of cosine is going to be 1. So the height is going to be 13, and we substitute with 1 plus 15. This is going to equal to 28. So the maximum height is going to be 28 meters. The maximum height is 28 meters. And we can also verify this graphically. Here we see 28, so that confirms that's the correct answer. Moving on to B, after how many minutes is the maximum height reached? So we can simply just we'll just go to the first one right here. So the maximum height is first achieved with 0 minutes. So t is going to be equal to 0. So we can write the maximum height is first achieved when t equals 0. And the cosine is max at t equals 0. And then again, so first the cosine is maximum at t equals 0, and it just keeps going on. 0.7, 1.4, 2.1, and so on and so forth. So we could write 0, 0.7, 1.4, 2.1, and etc. Okay, moving on to question C. What is the minimum height of the point? So the minimum of cosine is going to equal -1. So using this, we're going to use our function, and we're going to substitute it. -1 plus 15. This is going to be equal to 2. So the minimum height is 2 meters. And we can also verify this and see all these are 2. So this is correct. Moving on to D. After how many minutes is the minimum height reached? So that's just going to be a little tricky. So the cosine reaches -1 at halfway through the cycle, and half of 0.7 is 0.35 minutes. Okay. So our cosine here is -1, right? Like our minimum of cosine is -1, and halfway is 0.7 divided by 2. So 0.35, 1.05, 1.75, and so on. So we can write the minimum height is first achieved when t is equal to 0.35 minutes. Just gonna write here, and you can write 0.35, 1.05, 1.75, 2.45. And then etc. as there's more cycles. Okay, moving on to E. For how long within one cycle is the point less than 6 meters above the ground? So let's go to our first one right here, and we have to calculate from this point to this point in terms of time. So let's look. We'll grab this value right here, 0.26 and 0.44 approximately, 0.43. So we'll calculate that. 0.43 minus 0.26. So our answer is going to be around 0.17. This is our approximate answer. So we can say within one cycle, the time it takes to be below 6 meters is 0.17 minutes. Okay, and now moving on to F. Determine the height of the point if the wheel is allowed to turn for 72 minutes. So 1 hour and 12 minutes equals 72 minutes. So we're going to find 72 on our graph. Here's 72, and we just keep going up. And we're going to find 72. And we want to be very exact. So 72 right here, and it says 23.10537. So our answer is going to be the height of the wheel at 72 at 1 hour 12 minutes will be 23.1 meters. And that's our final answer for F, and that concludes our lesson.